You turn unusable into unyielding. These pieces of engineered origami are up to 3 times wider and considerably lighter than their molded cousins, with no loss of strength. The unique piles win the contract. But now, Kevin and the Earth Support team must turn 4,000 tons of steel into kilometers of reinforced walling. And they must do it fast, or they'll hold up the project.
We were the people that are out in front, and if we didn't perform, then the rest of the fellows down the line couldn't do their job.
A 5-ton vibro hammer, hooked up to a crane, drives the pile into the ground with 910 kilonewtons of force. The weight of a Boeing 737. With this power, the crew can install 45 meters of walling a day. Once a pond is complete, concrete hides the row of sheet piles. But beneath the facade is an armor-plated pond.
You could drive a semi-trailer at 100 kilometers an hour into this wall and it wouldn't affect it.
The ponds are back on track. Just in time for a major breakthrough. Gus and the smart team finished the excavation phase of the tunnel in record time, despite the cost.
We have done something that I would say nobody has ever done before. Great success, everybody was happy, and we can all be very, very proud of it.
The engineers can now begin the next phase of the smart tunnel, the 3-kilometer highway. This section will have 3 levels. The top 2 levels for traffic and the bottom level for stormwater. But this innovation creates a unique problem. When designing normal road tunnels, engineers only have to deal with loading from above, the weight of cars driving over the surface. But on this project, cars are only half the equation.
In SMART, we've got a particular unique situation where we have stormwater running underneath the road decks, under pressure. And that can be up to 2 atmospheres in pressure. So that's like having the equivalent of a 20-meter lake pushing up on the underside of the road deck.
The design is tested to find areas of high stress.
The identification of those high stress areas allowed them to pinpoint areas where we had to install dowels connecting the road deck to the tunnel lining.
Like engineering acupuncture, the small dowels, 20 millimeters wide and 370 millimeters long, transfer the load from the stress points into the stiff road section. With the problem solved in the virtual world, construction begins. But the design challenges are not over. When a major storm hits, this road will be flooded completely.
Well, there are various components in a road tunnel. There's lighting, CCTV, air quality monitoring systems, and all of these have to be watertight in our situation. It's a bit like taking your house, filling it with water, emptying it, cleaning it out, and then expect the lights to work when you turn them back on again.
When a flood is predicted in KL, the tunnel will be evacuated. The gates across the Klang River will be closed. The water from the river diverted into the holding pond. Less than 60 minutes later, the stored water will start pouring into the tunnel through the inlet pipe. The gates separating the highway will be opened, flooding the entire tunnel. Havinder Singh is the man responsible for making sure the evacuation procedure is fail-safe.
In a tunnel project like this, where you are going to have traffic running and then stopping the traffic and then running water through it, you cannot have any failures.
His company is designing the control and safety system for the entire tunnel. Operators will rely on accurate information arriving from monitoring devices inside the tunnel. But when the project started, waterproof versions of these devices didn't exist.
None of the equipment that is normally used for traffic or for motorway operation is actually designed to be submergible, especially up to 25 meters.
Everything that will go inside the tunnel must be designed from scratch. Then pressure tested. Security cameras, fire extinguishers, even the lights. If they pass, they become smart components. But a crucial piece of the flood control system is still missing. KL can go from situation normal to a full flood in under 2 hours.
And this kind of flooding can occur even if it's not raining in the middle of the city, but it's raining upstream.
If this epic battle is to succeed, they need a warning system that's foolproof. The Kuala Lumpur Flood Control Plan has multiple lines of defense. But if they are not deployed in time, the plan will fail. The solution? A warning system, faster than anything that has come before. Chris Godding is the Malaysian manager of Greenspan, the company designing the flood warning system.
If the predictions are wrong, if they don't accurately capture the flood, or if the wrong techniques are put into practice to divert the flood, then there is a very big chance that a loss of life could occur.
Chris's team uses computer models to help make the predictions.
So the model is what looks at the data that's coming in, the rainfall, the river levels, the velocities.
In a normal system, these models run every hour. But to keep up with KL's turbulent environment, Chris's models run every 5 minutes. To make these lightning predictions, Greenspan installs state-of-the-art monitoring stations out in the field.
The equipment that we've put into this system is at the absolute cutting edge of instrumentation, communications and process control.
The star of this high-tech monitoring show is a $15,000 cylinder called a Doppler velocity reader. The Doppler works like a speed camera. It fires radio waves at the water at a certain frequency. When the waves hit the water, that frequency changes. An inbuilt sensor calculates the velocity of the river based on the difference between the outgoing and incoming frequency. There are 28 stations around the valley, all feeding real-time information back to mission control. 4 years after it all began, the ponds are on standby. The barrages are ready. The warning system is in place. The smart tunnel set for action. And the diversion canals nearly finished. When finally complete, the Kuala Lumpur Flood Control project will be a true man-made marvel. A daring endeavor to control nature that will pay off tenfold.
I think it's quite a marvellous feat, the way they've managed to coordinate the tunnels, the ponds, the canals. I think the whole world would look at this as quite a significant achievement.
The team have overcome unique challenges and developed innovative new products.
It really goes to show, if there is a challenge that we need to solve, creative engineering can solve that.
And the revolutionary smart tunnel has set a new benchmark for the world.
Already other cities are looking at the smart solution as a way of overcoming some of their difficulties.
Now Kesral's goal is to bring nature back to KL.
Our job is not finished yet, because now we've got to look back. Having taken care of the flood, how do I bring nature back to the river?
But now Kevin and the Earth Support team must turn 4,000 tons of steel into kilometers of reinforced walling. And they must do it fast, or they'll hold up the project.
We were the people.
With this power, the crew can install 45 meters of walling a day. Once a pond is complete, concrete hides the row of sheet piles. But beneath the facade is an armor-plated pond to turn unusable into unyielding. These pieces of engineered origami are up to 3 times wider and considerably lighter than their molded cousins, with no loss of strength. The unique piles win the contest.
You could drive a semi-trailer at 100 kilometers an hour into this wall and it wouldn't affect it.
The ponds are back on track. Just in time for a major breakthrough. Gus and the smart team finish the excavation.
People are out in front, and if we didn't perform, then the rest of the fellows down the line couldn't do their job.
A 5-ton vibro hammer hooked up to a crane drives the pile into the ground with 910 kilonewtons of force. The weight of a Boeing 737.